Okay, so we're here for the second lesson of geometry. Hopefully you didn't have too much trouble with the lines, points and planes stuff, but if you did, just get in touch with me and I can solve any issues. We're going to start with the last thing I kind of mentioned in the last video, which was on this question here. It was, can we have two different lines going through 2 points A and B? So you have to think about this for a minute, but hopefully you did this and you drew a line between 2 points A and B. And then if I take a ruler here and I try and draw a line any other way, it's never going to go, even if I try through B, it's not going to go through A, and A, it's just only one way. There's only one way. It's right there, okay? So the conclusion of this question is no, we can't have two different lines going through 2 points A and B, because there's only one straight line that'll ever go through both of those points. So we're going to jump on to our friend Euclid just one more time. We're going to have a little think about what he wrote about in this book, The Elements, okay? So we're going to flick back to the very, very first chapter. He set out at the very start of this book things called postulates and common notions. And these are what we now call axioms today. And these are things that we don't question. You don't need to prove them, they're just there. One example is something that I'm going to go through now. It's this one here saying things which are equal to the same thing are also equal to one another. It's a little bit of a mouthful, but let's just break that down a little bit. Okay, I'm going to put this aside. Things which are equal to the same thing must be equal to one another. So here we go. Try not to be too scared of these letters. We have the letter A and we have the letter C. Let's say A is equal to B. And let's say C is also equal to B. So we have two things equal to the same thing. So therefore Euclid says A must equal C. Now, it does take a minute to get your head around these things, but when you think about it, it's obviously true. It's very clear that if A is equal to B and C is equal to B, then A must equal C. If two things equal the same thing, then they must be equal to each other. So, now that we've got our head around that, let's have a little look at what we call them now. We call them axioms now. An axiom. An axiom is a statement which is obviously true and requires no proof. So as we said, this is obviously true and it doesn't require me to prove it. I have proven it here, but we don't need to prove it because we're just going to accept these things. Our first axiom is the one that we just did up here. This is axiom number 1, that two different lines cannot go through 2 points A and B. There's only one line. The second axiom is all about distance. It's all about distance of lines and stuff. So I've drawn out this line here, okay? And I've just written down here page 148 in Connect with Maths. If you want to look over what's written in the book, that's where it all is. It's just all there on that page. So we've got this line. It's got 3 points on it, A, B, and C. And we have 4 rules that we're going to get out of this. I've got them written down beside me so I don't forget them. The first one is, now this is really, first of all, we need to just take a moment and understand what I'm about to write in terms of the notation. So we've got this thing. So we remember AB, which just means the line AB, right? These two lines beside it, they mean the length or the distance of AB. So the measurement of here to here. If I was to find out what that is using a ruler, we have that it's just about 4.5 centimeters ish. Yeah. So this means the length AB, which I'm going to write up here, the length of AB the length of AB is never negative. So I think we can all agree that the length of something can never be negative. You can't have a minus distance. And one thing back in the ancient times, back in Greece and Egypt, they were firstly, they didn't have negative numbers, but when people started to suggest a negative number, they got very confused, because the idea of having something that is not visible in the world, negative numbers, is just out of this world. So we can easily say that the length of this line here, or the length of AB, can never be negative. AB could be from here to here, or even from here to here, but it's never a negative number. It's a distance, and a distance is always positive. Let's take a moment to think about that. If I'm walking towards a tree, then I'm always going in a distance, and the distance between me and that tree it's always a positive number. It has to be positive. The second thing kind of goes back to our whole AB, CB thing that I did a minute ago. And this one here kind of goes back to this yoke. We're looking at the length of AB. So this notation, again, we're going to have to get used to this notation. The length of AB equals the length of BA. So remember, in the last lesson, I told you that this line AB can also be written as BA. So essentially, you can just write it this backwards, and it means the same thing. It's just looking at it from a different angle. So the length of A to B is the same as the length of B to A. I think we can all agree on that one. It's not too confusing. The next one takes a little bit of thinking. We have, if there's a point, if a point C, let's call it C, lies between AB, this line, then AB, the length of AB is equal to AC plus CB. Right, that's a lot of things going on. Firstly, there's a point, C. We have it here. The point C lies between A and B, so it's between these 2 points. That's okay. Then the distance of AB, so this distance, is equal to the length of AC, so this distance, A to C, plus C to B. So I'll do it with a few different colors that might help. So we'll keep A to B as being the black one, right? And I'm going to do green as A to C. And I'll do red as C to B. Now I'm just going to draw this kind of a thing here. This is just showing us that A to B, this is the full distance, okay? You get that? That this is just from A to B. So we're saying that AB, which is the green one, or the black one, sorry, is equal to AC, which is the green one, plus CB, which is the red one. Sorry, that red isn't really coming out. There we go. So it's hard when you look at it like this, but when we read it like this, it makes sense. We add this distance and this distance, and we get the big distance. Okay? So we just need to get used to this kind of notation. It'll come up a little bit more often when we're talking about this kind of stuff, but it'll be something you'll get as it goes on. And as I always say, these things you might not get straight away, but you can take your time and get used to it. The last one is worded really strangely, and it's even in your book it's very odd. It says there is only one point on this thing AB, which remember is called the ray AB, so it's starting at A, going through B and going on forever. Remember from last time. Which has a given distance. So this is really confusing, the way they word it. Has a given distance. What that means is, if I tell you that there is a point, say a point C, sorry, it's a given distance from A is probably easier to understand. Say a point C is, let's work this out first before I write it, in case, yeah, 3.5 centimeters from A. Okay. There is no other point 3.5 centimeters from A. Now, I know there's a lot of words and there's a lot of confusing things and it's going to be hard to understand it. Take your time, read it, listen to me do it a few times. So just to finish off on this point here, we have that we were saying that C is the only point on this ray AB that we can have that is 3.5 centimeters. We've given the distance 3.5 centimeters from A. It is 3.5 centimeters from A. There is no other point that could go 3.5 centimeters from A along here. Be careful though. It is a ray. Array AB. That means, remember what that means? That means that actually stops there and it just goes this way. If it wasn't and it went this way, well then maybe there is a point along here that's 3.5 centimeters from A as well. But we're only talking about the ray, so that's what's important. So just to recap, axioms, they're just a statement, but they're obviously a true. There's a few of them, there's a good few of them. The first axiom is that there's two different lines going through 2 points. That's not possible. There's only one line that can go through 2 points A and B. Second axiom, we have that the length of AB is never negative. The length of AB is always equal to the length of BA. If a point C lies between AB, then AB is equal to AC plus CB. So remember that green and red. Just take a little bit of time to think about that one. And also that there is one point, only one point, on the ray AB which has a given distance from A. So that's axioms.